So now it's time to shift our attention to the acceleration. So I've written down the acceleration equation here without all the subscripts and things so it fit in one line. And you know, I don't even use the equation, I just use it to remind me what parts are all here. So let's start with the acceleration of d. So if you look at this picture up here, d is on that blue arm spinning around a with an omega of 4 that's constant, which means alpha is 0. So d spinning around a is this, that's acceleration of d. So let me draw that in. So here's that little arm. We have point A down here. So the acceleration of d is going to be r omega squared, pointing towards the middle. And r was 0.2 and omega was 4. So 0.2 times 4 squared. There's no r alpha because alpha is 0. Okay? The acceleration of c, if you look back at the picture, c was that pin, which isn't even moving. So nice. That's 0. Okay, and all this stuff in the brackets here, again, I just want you to think d spinning around c, d relative to c, spinning around c. Or if it helps you, think of that point right next to d prime. Okay, so d spinning around c. So what we're going to do, let me just dot that in. There's c, there's d. Okay, shorten that so it'll fit in here. So this is point D. Sorry, on the recordings you're not going to see my erasing. Okay, so there is always r omega squared pointing back towards the middle, and it's d spinning around c. And so the length from c to d is 0.3 meters. Okay, and the omega, that's why you always have to do the velocity first. So the omega of that bar CB we got was 4/3. So times 4/3 squared. That's why you have to do the velocity first. This might have an alpha. So there's this component here. That's going to be r, 0.3 times alpha of that bar. And that bar, again, the letters are BC. And here's CB. Okay. I'm going to skip this 2 omega v rel for now. And let's just do A of c relative to d. So that's the acceleration along the slot that the camera sees. I'm just guessing that it's going away. If I get a negative for that, that means I guessed wrong. And so that's A of c relative to d. Okay, so now it's time for this 2 omega cross v relative. That's another reason you do the velocity first. You need to get that relative velocity. So we got, let me just write it down here. V rel was going this way, and it was 0.6924. And we got the omega was counterclockwise of 4/3. We got both of those things from the velocity part. That's why you have to do it. So I'm going to just write in the number. So it's going to be 2 times 4/3 times 0.6924. We'll multiply that out later. Okay? Okay, so this omega cross v rel is always perpendicular to the arm. And I don't want you guessing if it's downhill or uphill. You need to use the right hand rule. So I'm going to do omega cross v rel. So that 4/3 is counterclockwise, so I'm pointing my thumb up out of the paper. V rel is downhill, I'm pointing my index finger down in that direction, and then my middle finger then, the only way it can point, ends up being this way. Okay? And so that's the Coriolis acceleration. Okay, so what I'm going to do now is I'm going to clean it all up. I'm going to multiply all the numbers out, and I'll come back. Okay, so I've multiplied all the numbers out. I put in all the angles. And now we need to take components. So I'm not going to make the same mistake I made with the velocity. It's going to be way easier if I do these components, x and y, tilted along this 30 degrees. So what that means, everything on the right hand side is either at 30 or 60 degrees in the x and y directions, but I'm going to have to change that 3.2 into its components. So there's a component that way going in the negative x direction, and there's a component that way going in the negative y direction. I can see that this angle here is 30 degrees. So 3.2 sine 30 degrees is 1.6, and 3.2 cosine 30 degrees is 2.7213. Okay, so now all we have to do is take x prime and y prime components. Okay, so let's do x prime first, uphill positive. So that's minus 1.6 going downhill. That doesn't have a component that way. Minus 0.5333 going downhill. That doesn't have a component in the x prime direction. Plus a of c relative to d. So you solve for that. And a of c relative to d equals minus 1.6 plus 0.5333, and that equals minus 1.067. So 2 times in a row I guessed the direction wrong. So that means the a of c relative to d is actually going downhill. Okay, let's take the y prime components next. Excuse me. Okay, I'm back. I just had a little coughing fit there. Okay, so we're taking it up and to the left as positive, so the component 3.2 is going down and to the right, so minus 2.7213. Okay, this is going up and to the left, 0.3 alpha CB. This does not have a component in the y prime direction. This is going downhill, so minus 1.8464. Excuse me. And that doesn't have a component. Okay, just a minute. So while I was taking my little coughing break there, I just went ahead and solved it. So I guessed wrong again. Alpha CD turned out negative, minus 3.08 radians per second squared, which means I had guessed counterclockwise, so it means it's really going clockwise. So I've actually solved for all the unknowns, not just what was asked for the problem, but the original things we were supposed to find were omega CB and alpha CB, CD, sorry, or CB. This was alpha CB. Okay. So omega CB was 4/3 radians per second counterclockwise, and alpha CB was 3.08 radians per second squared clockwise. Okay, so I'll repeat this process for the next problem, the one that you actually turned in.